All right, so in this problem, we're going to take that same region that we just did in example 4. We just looked at it in example 4. But this time we're going to rotate it differently. We're asked to rotate it around the line y equals 2. Okay, so this is a little different. So I tried to draw it here. This is the region that we are interested in, the same, region between the lines y equals x and y equals x squared, right? And but now this time we're rotating around y equals 2. Okay, so we're going to rotate it this way. So what I did is I drew a mirror image up here on the other side of the line y equals 2. Y equals 2. And then I tried to draw what it would look like if it was rotated. Okay, so again, it kind of looks a little funnelish, where it's got kind of this big opening over here on the left side and then a little smaller opening on the right side. In this case, the outer edges are curved because they're defined by the y equals x squared. I guess I should deal with it down here. Y equals x squared, and the inner, which is y equals x. So actually I'm going to reverse that because I probably want to, I'm going to be drawing some more stuff and I don't want it to be too cluttered up there. All right. So now we just have to slice this thing up, right? We have to slice it up and then add up all those little slices. And we're going to get washers again because we have sort of an inner radius and an outer radius. So in this case, the outer radius is defined by the y equals x squared, and the inner radius is defined by y equals x. But I'm going to pause here. I'm going to try to draw what the washer looks like. All right, so I tried to draw what this washer looks like. We have this outer radius and an inner radius, and then so there's this washer with a hole in the middle. And actually, if I want to draw the thickness, if I draw this, oops, I'm going to draw it in the red color. I didn't draw the thickness of it on the inside, so you can kind of see if I draw this little. Okay, so I gave it some thickness, and the thickness here is delta x. So now we want to take the volumes of all these washers and add them up. Okay, so we need to find the volume of one washer. So we're going to take the cross-sectional area of the washer, okay, and then we're going to take it times the thickness, and then we're going to add up all those little washers. So to find the cross-sectional area of the washer, we're going to take the outside circle, which is defined by the outer radius. So let's first of all just figure out what the outer radius is. All right. So you could, okay, so let's look at the radius for where the radius is, the center is at 2, right? So if I drew the center here, and so, we can come down by 2, right? But then we have to subtract the amount back up to the basically we're subtracting the value of the outer curve, okay, to get back up to the place where the outer curve is. So we're gonna take 2, and then we're going to subtract x squared to get the outer radius, okay, because we're going to come down 2 and then go back up by the amount of the curve, right? And the same way with the inner radius. Inner radius. We're going to take 2 and then subtract that inside curve, which is the y equals x curve. So we're going to get 2 minus x for the inner radius. So now we're going to integrate all these washers from 0 to 1. All right, and we're going to take the outside circle, right? So we're going to take pi of the outer radius squared. So we're going to get 2 minus x squared, right? And then we're going to subtract the inside area. So pi times 2 minus x squared. And then dx, okay? And that'll give us, if we add those up all the way from 0 to 1, then that'll give us the volume that we're looking for. All right, now it's just a lot of algebra and calculus, right? let's factor out a pi. And then we'll integrate from 0 to 1. And let's expand these squares. All right, so if I expand the first one, I'm going to get 4 minus first times last times 2 gives me 4x squared. And then the last squared gives me x to the 4th. And then minus the whole quantity. So we're going to get 4 minus 4x plus x squared. Okay, and then all of that, so I may put some additional brackets around it, dx. All right, so let's clean this up a little bit. We need to combine some terms. Now we have 4 and then minus 4, so these two 4s will just go away. And then this x to the, so we have x to the 4th, okay. And then I can combine these two x squared terms. So we have minus 4x minus, 4x squared, minus 4x squared, and then minus x squared becomes minus 5x squared. And then we have this minus a minus 4x, which becomes plus 4x. And I think that takes care of all the terms. dx, all right. Then we have to take the integral of all of these things. So this becomes 1/5 x to the 5th minus 5/2 5/3 x cubed. And then we're going to have then 1/2 of 4, so that's going to be 2x squared. Okay, and evaluate that from 0 to 1. And what do I get? Let's see. I've got pi, and then now when I evaluate everything at 0, it's just 0. So really all I have to do is evaluate it at 1. So I'm going to 1/5 minus 5/3 plus 2. Okay. All right, so that's 3/15 minus 25/15 plus 30/15. So I'm going to end up with 8/15 times pi. And that is my area.